Hey everyone. So did you know that right now, as you're watching this, there's a massive, almost invisible upgrade happening to the very foundation of the internet? It's something you use literally every second you're online, but probably never think about. Okay, let's get into it.
Let me start with a question for you. What if the internet just ran out of room? I mean, seriously. Imagine our digital world is like a city, and there are only so many street addresses. What happens when you've built on every single lot?
Well, here's the kind of shocking part. In a way, it already has. The original system of internet addresses actually hit its limit a long time ago. So, how is anything new still coming online? Well, that's the amazing story we're about to unpack.
To really get our heads around the brilliant solution, we first need to understand just how big the problem was. And it all boils down to one thing: the IP address.
The easiest way to think of an IP address is exactly like a mailing address for your house. When you want to check out a website, your computer sends out a request, and that website needs your address to send all the pictures and text back to you. Every single thing that connects to the internet, your phone, your laptop, your gaming console, you name it, it needs one of these unique addresses.
Now, the original system, the one the internet was built on, is called IPv4, and it had about 4.3 billion addresses available. Back in the early days, that seemed like an astronomical number. I mean, more than we could ever possibly use up, right?
Wrong. Because then, well, the modern world happened. Suddenly we had smartphones in every pocket, laptops, tablets, smartwatches, smart TVs, even smart refrigerators and security cameras. Everything needed an address. And all of a sudden, 4.3 billion wasn't nearly enough. The internet was, for all intents and purposes, full. We had a genuine address crisis.
And this is where the hero of our story makes its entrance. To solve this critical shortage, engineers developed a brand new, completely future-proof system, Internet Protocol version 6, or as we all call it, IPv6.
So how many new addresses are we talking about with IPv6? Take a look at this number. That is 340 undecillion. It's a number so outrageously large that our brains can't really even comprehend it. We went from 4.3 billion to that. To try and put that into perspective, 340 undecillion is enough to give a unique internet address to every single grain of sand on planet Earth, and still have plenty left over. So the bottom line here is pretty simple. We are not going to run out of internet addresses again, ever.
Okay, I know what you're thinking. That's great, but those new addresses look crazy complicated. And you're not wrong. They can look pretty intimidating at first glance, but they actually follow a couple of really simple rules.
So here's a typical full-length IPv6 address. You can see it's way longer than the old ones, and it uses both numbers and letters from A through F. It's what we call hexadecimal format. But let's be honest, nobody wants to type that whole thing out.
And luckily, you don't have to. There are two simple tricks to compress them. First, you can just drop any zeros at the front of a block, and second, you can find the longest string of blocks that are all zeros and replace that whole section with a double colon. Just remember, you can only do that double colon trick once in an address.
And just like that, our long, clunky address becomes this much shorter, cleaner version. See? Not so scary after all. But this upgrade is about way more than just making room for new devices.
So yeah, solving the address crisis was the #1 goal. But the creators of IPv6 took it as a golden opportunity to build a better, more efficient, and more secure internet protocol right from the very beginning.
The most obvious upgrade here is the jump from a 32-bit address to a 128-bit one. That's what gives us that mind-boggling number of possibilities. But check out that last row, NAT needed. This little detail points to one of the biggest improvements.
So what the heck does no more NAT actually mean for you? Well, NAT was a clever workaround for the old IPv4 shortage, but it added layers of complexity and could even slow things down. With IPv6, every device can have its very own unique public address, which allows for a true, direct connection from end to end. That, plus a simpler data structure, means more efficient routing, and that can lead to better performance for things like gaming and streaming.
IPv6 also got a lot smarter about how data is sent. The most common type is called unicast. This one's easy. It's just one device sending data directly to one other device. It's the digital version of mailing a private letter to a single house.
Then we have multicast.
This is for one-to-many communication. Think about a live stream. Instead of the server sending a separate copy of the video to every single person watching, it sends out one single stream, and only the devices that have subscribed to it will pick it up. It's way, way more efficient.
And finally, there's a really cool method called Anycast. This is a one-to-nearest approach. Let's say you're trying to access a huge service like Google or Netflix. Your request gets sent to an Anycast address, and the network automatically routes you to the server that's physically closest to you. This cuts down on lag and makes everything feel faster.
So with all these awesome benefits, you might be asking, why haven't we switched over completely? Well, you can't just flip a switch on the entire global internet. It's a massive, ongoing process. And for right now, we're basically living in two worlds at once.
The most common way we're handling this transition is a strategy called dual stack. It's actually really simple. Your phone, your computer, your internet provider's network, they all just run both protocols at the same time. When you try to connect to a website, your device checks if it supports IPv6. If it does, great. If not, it just falls back to the old IPv4. It's totally seamless to you.
Another clever trick we use is called tunneling. Imagine you need to send a new, large package, but it has to go through an old mail system that only accepts small envelopes. What do? You put your package inside one of the old envelopes. That's pretty much what tunneling does. It wraps up a new IPv6 data packet inside an old IPv4 packet to get it across a part of the internet that hasn't been upgraded yet.
And this isn't some theoretical thing for the future. The transition is happening right now, and it's well underway. In major countries like the US and India, IPv6 adoption is already over 50%. The new internet isn't coming. It's already here, and it's growing bigger every single day.
At the end of the day, IPv6 isn't just a maintenance update. It's a fundamental expansion of what the internet can even do. It lays the groundwork for a future where every single device imaginable can have its own direct, secure place online. And that leaves us with one final big question. With the virtually infinite and more direct internet, what new innovations are going to be possible that we can't even begin to imagine today?